Hello and welcome back to Embroidery with Z. This week I have another fun DIY for you. We're going to be embroidering a JAK stat signaling t-shirt. So remember, JAK stat signaling is the mechanism by which EPO, which is a cytokine, allows survival or differentiation of erythroid progenitors. So this is a really important mechanism and it's really fun and stylish. So let's go ahead and get started on that t-shirt. Okay, so before we get started, I actually want to kind of talk about the materials that you'll be needing for this DIY. So the first thing that you need is what you see on the left, which is Janus kinase, or JAK. It's a receptor-associated tyrosine kinase. And what it does is it's going to be phosphorylating our stat by phosphorylating tyrosine residues. And then you're also going to need a ligand. I like to use EPO as my ligand, but if you don't have an EPO and if you want some more diverse effects, you can use another ligand. Some other materials that you're going to need are the EPO receptor, which is embedded in the membrane, and also you're going to need STAT, which is a regulatory transcription factor. And here we actually have a STAT dimer, but we'll see it as a monomer first. Okay, so the first step is going to be to go ahead and embroider your cytokine receptor with no ligand bound, and just use a transmembrane alpha helix to stick it into your cell membrane. And for your next step, you are going to bring in your ligand, and it's going to bind to the ligand receptor, causing the receptor to change conformation. And now the two parts of the ligand are going to be brought closer together, which gives the JAKs, which are associated with the receptor, some kinase activity, but just a little bit. Now that the JAKs have kinase activity, you're just going to go ahead and let them phosphorylate each other. So first, this one on the right is being phosphorylated, which you can see with the little red knot. And now the one on the left is being phosphorylated, and as always, both of these phosphorylations require 1 ATP. So now this new conformation that you've embroidered is going to cause your Janus kinase to be super active, and so now the JAK is phosphorylating more things, so it's actually going to phosphorylate sites on the cytoplasmic section of the receptor. The cytosolic stat, which was one of the materials that you started with and was already floating around in your t-shirt cytosol, now has really high affinity for the phosphorylated receptor, so it's going to come in and bind the receptor. And once stat has bound, you're really almost done with your t-shirt. All that's left to do is for JAK to phosphorylate stat, because now JAK will just phosphorylate anything. And you can see with a little red knot on stat that it has been phosphorylated. And phosphorylated stat actually dissociates from the receptor and dimerizes with another stat. So go ahead and embroider that. I just put it below. And the dimer has an altered conformation from just the stat by itself, and it's going to have its NLS exposed, which is why the dimer of stat gets transported via important to the nucleus, and then it's going to be able to bind a promoter or enhancer and induce genes that can block cell death or promote cell division. So don't forget to embroider a little DNA double helix to indicate that the stat dimer is a transcription factor, a regulatory transcription factor that will affect gene expression. And that's all you need to do to embroider a JAK stat t-shirt. It's really quite simple and fun, so I hope you all try it out. And this is what it looks like on. I like to style it with my favorite DNA hat, and I think it looks really good. So I will see you guys in the next video. Bye!